This video discusses some applications of differentiation still using the long method solution. Check it out here in differential calculus. The first example involves a cylinder of fixed height of 6 units. It requires the rate of change of volume with respect to the radius of the cylinder's base. To start with the differentiation, we need to identify the equation for a cylinder's volume which involves its radius, and that is the area of the circular base multiplied by the height. Mathematically, we write this as V is equal to pi r squared times h, where the problem states that the height is fixed at 6 units. Therefore, we have V is equal to pi r squared times 6, or that is V is 6 pi r squared. This is the working equation that we are to differentiate. So start with step 1, which is replacing variables with the additional deltas, making the equation V plus delta V is equal to 6 pi times the square of r plus delta r. Now expand the squared binomial to have V plus delta V is equal to 6 pi times the quantity r squared plus 2r delta r plus delta r squared. Then remove the parentheses by distributing 6 pi. The next step is to isolate delta V, so we transpose V to the other side of the equation, and since V is pi r squared h, note that we are able to cancel out 6 pi r squared, reducing the equation to delta V is equal to 12 pi r delta r plus 6 pi delta r squared. In step 3, we integrate delta r into the equation by division, and this operation cancels out many delta r's, resulting to delta v all over delta r is equal to 12 pi r plus 6 pi delta r. Lastly, we determine the limit of the equation as delta r approaches 0, where we zero out the second term, leaving the equation dv all over dr is equal to 12 pi r. The second example is similar with the previous one we discussed, though there is a slight difference of the height, which is 10 units. So still the same, the volume of the cylinder is its base area multiplied by its height. And since we have identified the height as 10 units, the working equation for this example is V is equal to 10 pi r squared. Now start with the variable replacement. So we get V plus delta V is equal to 10 pi times the square of r plus delta r. Then expand the binomial to simplify the equation, and this results to V plus delta V is equal to 10 pi times the quantity of r squared plus 2r delta r plus the square of delta r. And then distribute 10 pi to arrive at V plus delta V is equal to 10 pi r squared plus 20 pi r delta r plus 10 pi times delta r squared. Next is to isolate delta V, and that is by transposing V to the other end of the equation. V has been defined as 10 pi r squared, and plugging this as V cancels out the other term, making delta V as 20 pi r delta r plus 10 pi times delta r squared. The third step is to divide the equation by delta r, which cancels out many parts of the terms, leaving the reduced equation delta V all over delta r is equal to 20 pi r plus 10 pi delta r. Finally, find the limit of the equation as delta r approaches 0, which means that any term with delta r will be reduced to 0, leaving the equation dv all over dr is equal to 20 pi r. The next application is for the volume of a rectangular prism of dimensions b, b plus 1, and b plus 4. The volume of a box is the product of its length, width, and the height. So V is taken as b times b plus 1 times b plus 4, which can be simplified as we eliminate parentheses into V is equal to b cubed plus 5b squared plus 4b. So with step 1, all V's turn into V plus delta V, and all B's turn into B plus delta B. Our next move is to eliminate groupings, so we expand quantities. For B plus delta B cubed, we use the coefficients 1, 3, 3, 1. And B plus delta B squared gives 1, 2, and 1. Place these terms all together in a single equation, and distribute 5 into the quantity to come up with V plus delta V is equal to B cubed plus 3B squared delta B plus 3B delta B squared plus the cube of delta B plus 5B squared plus 10B delta B plus 5 times the square of delta B plus 4B plus 4 times delta B. Now we can isolate delta V, and that is through transposing V to the other side. Take note that V is b cubed plus 5b squared plus 4b. And when the negative sign is distributed among the terms, several terms are cancelled out, leaving us with the equation delta V is equal to 3b squared delta B plus 3b times the square of delta B plus the cube of delta B plus 10b delta B plus 5 times the square of delta B plus 4 times delta B. The third step is to divide everything by delta B, and this cancels out many parts of the numerator. So the resulting equation is delta V all over delta B is equal to 3b squared plus 3b delta B plus the square of delta B plus 10b plus 5 delta B plus 4. Lastly, look for the limit as delta B approaches 0. And by doing so, all terms with delta B zero out to leave us with the rate of change of the volume to B as dV all over dB, which is equal to 3b squared plus 10b plus 4. Again, example 4 is very similar with the last one, but the change of constants. So we take the volume by multiplying the three dimensions, arriving at V is equal to b cubed plus 5b squared plus 6b. Now we begin the differentiation by replacing variables and adding deltas. So we get V plus delta V is equal to the cube of B plus delta B plus 5 times the square of B plus delta B plus 6 times the quantity of B plus delta B. Expand the quantities and then again distribute the 5 to eliminate the parentheses, and get V plus delta V is equal to B cubed plus 3b squared delta b plus 3b times the square of delta b plus the cube of delta b plus 5b squared plus 10b delta b plus 5 times the square of delta b plus 6b plus 6 delta b. The second step is to isolate delta v, which is just identified from the premise as v is equal to b cubed plus 5b squared plus 6b. Place this in the long equation and it helps in the reduction as b cubed, 5b squared, and 6b cancel out, giving a reduced equation of delta v is equal to 3b squared delta b plus 3b times the square of delta b plus the cube of delta b plus 10b delta b plus 5 times the square of delta b plus 6 delta b. The next move is to divide everything by delta b, and the resulting equation turns out as delta v all over delta b is equal to 3b squared plus 3b delta b plus the square of delta b plus 10b plus 5 delta b plus 6. If we take the limit of the equation as delta b approaches to 0, we are left with the equation delta v all over delta b is equal to 3b squared plus 10b plus 6.